what I want to do in this video is get ourselves a little bit more comfortable with the idea of strings and also see the power of strings and all the things we can do to them or do with them. So what I'm going to do up here is I'm going to write a little simple program that will essentially just define a bunch of strings for me. And then I'm going to use the Python interpreter to play with those strings and see what we can do to them. So let me define a string. Let's call the string A. And A is, let's call it my first test string. My first test string right over there. And as we know, a string is just a big sequence of characters right over here. And you could recognize them because they'll either be in single or double quotation marks. And just to make clear that it doesn't have to be double, let me define B. Let me define B to be another test string that I have defined. And just to clarify on how you can define strings, you can actually put quotations within the quotation marks as long as it's clear where the string begins and ends. So let's say you have something like this. So let's say you say this is Sal's string. This is Sal's string. So in this example, this apostrophe is okay. It's a single quotation, but it's okay because the interpreter will know that, look, the string starts with a double quote, so I have to look for another double quote for it to end. So it's not going to say, oh, it ends at the single quote. It says I need to end with a double quote. So it knows that this whole thing is a string, and it also knows that this apostrophe is just a character. One thing I couldn't have done, I can't do, let's try to define string D here. So let's say, let me define it this way. So I couldn't have done this. This is Sal's string. This doesn't make any sense because here we're opening with a single quotation, then it'll close right when we get to the next quotation. And so all of this is just going to be some text that the interpreter is going to try to view as some type of program, and it's going to break on that. So if you want this to work, you can't have it like that. You could do something like Sal's. No, you can't do that. So my favorite, and there are ways to do that, and we're not going to go into escape characters and all of that right now. But my favorite word is, and actually I don't know what my favorite word is. I'm kind of putting myself on the spot. But let's say my favorite word is asparagus. I can't even spell it. Asparagus. So my favorite word is asparagus. What is yours? What is yours? So once again, this is legitimate because I start my string with a single quotation mark. So it says, look, let's not end the string until we get to another single quotation mark. So it's not like it'll confuse the interpreter when it sees this first double quotation because it knows that the string started with a single quotation. Let me show you some other examples of strings. And these will be interesting to deal with. And they don't always have to be named labels. So this is, let me call this my math string. Let's just call this a math string. And let's call this, let's say this is 3 plus 4 times 2. So that's a math string. It's literally just a string of characters. It doesn't, the interpreter won't evaluate it. It literally just views it as a string of characters. So I think this is a pretty good. Let me do one other kind of pseudo math string, or let me do another expression. Let me call this an expression string. So that's just the name of the variable. And let me say my expression string is let's say it's A plus, and then I'm going to have a kind of a string inside of that string, plus B plus tiger, right over there. So this is just, so everything in between the double quotation marks, the interpreter was just going to view as a bunch of characters. But there are interesting things that we might be able to do with this eventually. So that's enough strings for me to define. So let me save this file right now and let me run it. And what this does now in this environment, all of these strings are defined. And I can verify that. I can say A, my first test string, B, another test string that I have defined, C, this is Sal's test string, D, my favorite word is asparos. I couldn't even spell asparagus properly. Maybe we'll have to fix that. Asparos, what is yours? It needs the G, asparagus. What is yours? And then we have, it's a good thing this isn't a spelling video. We can look at what math string looks like. Math string is literally that string of characters. And then we have the expression string. The expression string. Literally just that string of characters. Now let's start to play around with some of these strings and see what we can do with them. So a couple of things, we could see, hey, how long is a string? And there we could use the built-in Python function len, which is short for length. So the len of a says, hey, there's 20 characters in A. Let's count it. Let's verify it. 1, 2, space is a character. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes, 20 characters. What's the len of math string? Math string, len, length for short. Math string is 5 characters. Let's count them. 1, 2, 3, 4, 5 characters. Makes a lot of sense. We could do it for any of them. And I encourage you to try this out yourself. Really experiment. Become comfortable with this. Now, the next thing I want to do is show you how to concatenate two strings. Sounds like a very fancy word, but it really just means connect them together. So, for example, I would say, let's create a new string. Let's call it A with B. A with B. And I'll define it as A plus B. So I'm doing something very interesting here. You're used to using the addition operator with numbers. But I'm about to add two strings. Let's see what this looks like. So let's look what A with B looks like. A with B is just a variable. Now what happened? I had A, which is my first test string, and I had B, which is another test string that I have defined. When I took A plus B, it took A, my first test string, and it added B to the end of it. It concatenated B to A. Concatenate is just a fancy word for put them together. Another test string that I have defined. So it merged A, I guess you could view it as it put B at the end of A. And you could go the other way. You could call it B with A. Let's say that is B plus A. And then let's look what that looks like. B with A. Now it's the other way around. A is added to the end of B. So you can do very, very fascinating strings. You know, if we did math string plus expression string, math, I'm not going to set it to any variable. I'll just see what I get if I evaluate that. Math string plus expression string. Then I essentially got these two strings added together. And so this string got put at the end of this string. And you see it right there. And it's this kind of bizarre looking string. But it is a string. Everything between these characters, everything between the double quotation is just viewed as a character. These are just characters. Now, there's many, 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 many other things we can do with strings. I'm not going to introduce you to all of them. But strings come with a bunch of functions. And if you have an integrated development environment, it'll often tell you what types of functions you could use. For example, you might want to split. Maybe you want a list of all of the words in a string. So maybe I'm writing some type of program. And I want to take this string that's in B. And I want to put each of these words as a separate element in a list. So what I can do is I could say B dot. And I'll call one of the methods of B. And we'll do much more on methods and object-oriented programming and all of that. But we can view B as a string object. And it has its own methods that can operate on itself. For now, you can just say, look, if I want to split B into its component words, I can call the split method. I could call the split method. And I can say, what do I want to split it on? So when I say split, I mean separate this string into a bunch of things and put them into a list and split the string wherever I see a space. So let's see what we return when we get that. So notice, it took this string, another test string that I've defined, it separated the string wherever there's a space and took what's on either side of the space and put it as an element in a list. Could be useful if you're doing some type of text processing. But I want to show you it doesn't have to be split just where you have a space. You could say B dot split, and you could split whenever there's a T. So you can split on the T, and this will give you some bizarre looking thing. So notice, every time there was a T, it split the string there, and it put what was ever on each side of those T's, it put them into a separate element in this list over here. So very fascinating things. I mean, you can do things like finding where a character is in a string. So let's say you want to call, I don't know, let's try the math string. And I want to find in the math string, so it's one of its methods, I want to find that asterisk. Another word I have trouble saying. So find the asterisk. Tell me which character, if any, has an asterisk in it. It tells us the third character does. Let's verify it. So this is the first character. This is the 0th character. That's the beginning. That's the convention in most computer programs. 0th character, first character, second character, third character is an asterisk. If you wanted to find the 3, and I really encourage you to experiment with this. Find the 3. It's the 0th character there. Now, there's other stuff. You can replace characters. You can say, look, let's take, I don't know, let's take C and let's replace all of, and you can either look it up in a book or just do a web search. You can normally find all of the libraries for Python strings. Or if you have an IDE, integrated development environment, it'll suggest things that you can do to strings and how you do it. But let's say we want to replace in string C all of the i's. We want to replace all of the i's with o's. Let's see what we get. So there you go. This is Sal's favorite. This is Sal's string. When you replace it with O's, and I want to be clear, it didn't change string C. It created a copy of C with the I's replaced by O's. So then it became das os Sal's strong. It sounds like I don't know, like a Nordic language of some kind. And just to be clear, C did not change. But if I said C equals C dot replace, and replace the I's with O's, then C has changed to das os Sal's strong. Now, the last thing I want to do is show you kind of a very magical function, at least from my point of view, and that's the eval function. And it exists in interpreted languages like Python, and it also exists in JavaScript. And what's really cool is it can evaluate a string. It can view a string. You can treat it as a string for a while, and you can construct it. So you could, for example, have a computer program that writes another computer program inside a string and then evaluates that, computer program. So that should get you philosophically thinking a little bit. So for example, if I just say math string, it's just a string of characters. But if I say eval math string, the interpreter will actually evaluate what's inside of this. So it'll actually treat it as an expression. And so I get 11. So it takes math string and says, OK, now let me treat that as like a program. So it's 3 plus 4 times 2. Order of operations does the 4 times 2 first, so that's 8. 3 plus 8 is 11. And you can do even cooler things. You could do eval. Let's think about this. Math string. And let's add to math string a character, the character 1. And let's see what it gets us. It gets us 87. What did it do? Well, what it did is, math string is this stuff. But if you add a 1 to it, it would look like that. The 2 would become a 21. We're concatenating a 1 to the end of it. So it became 4 times 21, which is 84, plus 3, which is 87. And you can do other things. We can evaluate this expression string right over here. That's why I set it up like that. Eval expression string. Eval expression string. Really fun to play with. I could do this all day. Eval expression string. Remember, expression string is just a string, but when we evaluate it, you might want to pause and think what you're going to get. So let's evaluate it. I got all this craziness. Where did that come from? Well, in the string, these were just characters, A and B. But when I evaluated in our current context, A and B are variables, and they represent strings. So when you evaluate this thing, it's going to say, OK, A is a string. That's my first test string. Concatenate, or put this space at the end of it. So my first test string, and then I have a space. And then put B at the end of that. So another test string that I have defined. Another test string that I have defined. Then put a space tiger. And then you have a space tiger. So I'm going to leave you there. As you can imagine, strings are super, super duper powerful concepts for doing a bunch of applications. And I encourage you, and I haven't exhausted anywhere near all of the functions or things you can do with them. So I encourage you to experiment.